If we take a look at one element of factorising quadratics then, so difference of two squares, and we have a few special cases here. So our general rule is a squared minus b squared equals a plus b upon a minus b, and we can use that system then to factorise some kind of special quadratics. So the first one here, the square root of 81x squared is going to be 9x, so it's going to be 9x minus, and then the square root of this 5y, in fact we'll do that one plus, and then 9x minus 5y, and I don't know if you can see, if you sit and multiply that out, it's going to make it work. So you have 9x times 9x is 81x squared, that's 5. Then we go for outer, which is minus 45xy, and then inner is plus 45, so that always disappears, those two middle terms, and then the last term is minus 25y squared. So that's what makes that work. It says then evaluate this, so we want to use it to help us do this calculation, so we should be able to make this work. So this is going to be 2.15 take away 2.05, and then 2.15 plus 2.05. 2.15 take away 2.05, what's that, 0.1? Isn't it? It is. And then adding these, we're going to get 4.2. So if we multiply those together, we get 0.42. I think should be the answer then to that. Next page then. Use the difference of two squares to simplify this. So this is our a and this is our b. So it's going to be a plus b upon a minus b. So it's going to be 3x minus 2 plus 5x plus 1 all upon them, but we're going to subtract them, so 3x minus 2 take away 5x plus 1. So simplifying this is going to give us, what does that give us? That gives us 8x minus 1 and 3x minus 5x minus 2x, and then minus 2 minus 1 minus 3. If we multiply this out, there's going to be first is minus 16x squared outer minus 24x inner plus 2x, and last is, plus 3. That gives us minus 16x squared minus 22x plus 3. Next bit then, when an expression has four terms in it, it can sometimes be factorised by removing a common factor from two pairs of terms. So look here, you can see there's a common a, so if we take that out, that's going to give us a upon c plus d plus b upon c plus d, and it's a bit like our quadratics we were doing earlier. We end up then with an a plus b upon c plus d. Similarly down here, so what are our common factors? Here we can take out an x upon y plus 3z squared, and then minus a, we're looking for the same thing in here again, y plus 3z squared. That gives us x minus a upon y plus 3 z squared. That's that example. Example 3. Then this one I think is maybe going to require a little bit of tidying up. I can see that there's a b squared there and there's a b squared there, so we can make those kind of the first terms. I don't know if this will work or not. Let's see. 3ab squared minus 2b squared plus 3a. That was maybe a silly thing to do. Let's go. So really, there's nothing we can take out of that. No, let's try that again. Sorry. Apologies. Looking for something that we can take out a common factor of. Unless we say I want to put the b squared bits together and then take those out. So if we go with 3ab squared minus 2b squared plus 3a minus 2. I think that one's going to work for us. That's okay. We can take out a b squared here. 3a minus 2 plus 1 upon 3a minus 2, and we're there. So we have b squared plus 1 all upon 3a minus 2. So you notice I got it wrong first time, but sometimes you just want to try to rearrange this. This is just this, only it's just been written the other way around, and that's the way then really we'll work it. So I rearranged it the first time, it didn't work out, so I've tried it again, and I've managed to get then the common factors we can bring out. So hopefully that makes sense to people okay. A couple of mixed questions then just to finish off. So we have a 12x squared minus 75. That's not a square number, that's not a square number, so we can't do that as yet. However, I can see that 3 goes into both of those, so let's take that out and see what happens. 4x squared minus 25. Now, wee alarm bell is now ringing with me, realising 4 is a square number and 25 is a square number, so this is now inside the bracket, a difference of 2 squares. So that's 2x minus 5 upon 2x plus 5. And so many people miss that second wee bit there. And you need to be careful with that one. Example 2 is tough enough as well, so there's a few different bits and pieces. First of all, I can see there's a common factor of 3 to take out. Anytime I'm factorising a quadratic, I like the squared term to be positive, so I'm actually going to take out a minus 3. So if I take out a minus 3 and then rearrange this, I hope you can see what I'm doing here. That's going to give me a 2y squared plus a 3y and then minus 20. I'm looking for two numbers that multiply to give minus 40, and the same two numbers add then to give 3. So we're looking for factors of 40 effectively where the gap is 3, so I think 8 and 5 are going to work for us. So we have minus 3 upon 2y squared plus 8y minus 5y minus 20. I do my little line down here. Minus 3 upon, right, what do I need to do here? There's a 2y comes out there, that's going to be y plus 4, and then minus 5 upon y plus 4, doing that half. That gives me minus 3 upon y plus 4 upon 2y minus 5, and that would be a factorised fully. There are other options where you can keep the 3 in one of those two brackets, but I think that's probably one of the tidiest ways of doing it. Hopefully that makes sense.